Hello learners, and welcome to today's lesson of Euclidean geometry, circles. Let's get to our lesson. So as we know, when it comes to Euclidean geometry, we have those theorems that we are working with. But in today's lesson, we are just going to focus on those five theorems. And of course, we are going to see these theorems in practice. Now, by the end of this lesson, we will address how to apply the theorems of circles in different scenarios, because usually we do know what the circles or the theorems say, but we cannot apply them. And then when it comes to the keywords and language, when it comes to working with circles, these are the keywords that you should always keep in mind and always know what they mean. Then looking at the common errors and misconceptions when it comes to the theorems is that the learners do not know the theorems well enough. So you need to know them well enough such that you can even recognize them when they appear to be hidden. The learners do not know how to apply the theorems to questions. So we don't know how to apply those theorems to questions, even if we might know them. And lastly, the learners do not know what it means to subtend an angle. We are going to address this misconception as well. What is to subtend? Then looking at those skills that we need for the exam, make sure that you keep in mind these skills that are needed. And then what should you know or be able to do from grade 10 and 11? Well, firstly, you need to know and understand the geometry rules previously learned, such as the interior angles of a triangle add up to 180, angles on a straight line add up to 180 degrees, vertically opposite angles are equal, and the exterior angle of a triangle is equal to the sum of the interior opposite angles. I'm sure those sound familiar, as these are things that you have learned in previous grades. For now, let's go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. Now remember, we are going to focus on those five theorems, and you will see these theorems not individually but within a given question. Then we will see how we can apply those theorems within our questions. Let's start by addressing the content and skills problem when it comes to the theorems. Well, learners do not know the theorems of circles properly. That is definitely the first problem. And then also, learners do not practice enough to familiarize themselves with the different types of questioning. So you need more practice so that you can recognize the type of questionings that will appear in exams. When it comes to the exam, learners do not know how to apply their knowledge of theorems to the given question. So you don't know how to apply the theorem even if you do know it. And again, learners struggle to associate the theorems when variables are used instead of values. So when we are using variables, your x and your y, you struggle to associate those theorems just because no values were given. But of course, we want to make sure that we fix this problem. What are the key theory aspects that you should know from grade 10 right up until grade 12? Well, the line drawn from the center perpendicular to the chord bisects the chord. The perpendicular bisector of a chord passes through the center of the circle. The angle subtended at the center is twice the angle subtended at the circumference. The angles subtended by the same or equal chords are equal. The opposite angles of a cyclic quadrilateral are supplementary. That means they add up to 180. The two tangents from the same point to the same circle are equal, And lastly, the angle between a tangent and a chord is equal to the angle subtended by that chord. So those are the key theory aspects. Let's look at a first example. So there we've been given a diagram, and it says there, P, M, T, and R are points on the circle with center O. So we have been told that O is the center. That is very important because we know that some of our theorems include those with the center. Then radii OM and OR are drawn. T1 or angle T1 is equals to 148 degrees. And P angle MO is equals to 18 degrees, and angle S is equals to 43 degrees. Now we're going to start by analyzing the diagram because before we can even look at the questions. And when we analyze the diagram, we do see that there is a cyclic quad. How do we know that it's a cyclic quad? It's because all of the points are on the circumference of the circle. So we're going to think of a cyclic quad. We can see that there is an exterior angle of a cyclic quad, so that's something to also keep in mind. And we can also see that there is a center, which means that there's an angle at the center, which means there will be an angle at the circumference as well. Now that is only us now analyzing that diagram, but let's see how we can solve for the questions. So looking at the first question there, it says to us, calculate with reasons the size of P. Now we can see where P is placed there, and there it is. But remember, we did see that there is a cyclic quad here. So we can see that angle P and angle T, they will be equals to 180 because the opposite angles of a cyclic quad. So the opposite angles of a cyclic quad, they add up to 180. And of course, when we substitute angle T there, we've got P giving us the value of 32. And now that we know that P is 32, we need to fill it into our diagram so that it can help us in answering other questions. The second question there says, calculate with reasons the size of O1. Now, O1 is the angle at the center. Now, is any theorem coming to mind? Yes, you are correct. Angle at the center is twice the angle at the circumference. That's why we are given now, or we can write down the equation that says that O1, which is the angle at the center, that one is twice the angle at the circumference, which is P. And the only reason why we can associate them is because both of them are coming from point M and point R. So the angle subtended at the center is is twice the angle subtended at the circumference. Now that means that our O1 is equals to 64, since as well our angle P is equals to a 32. Moving on to the next question. Now remember, you have already calculated angle P and you have already calculated angle O1. So make sure that those angles are there. Now we are asked to calculate the angle OMS. Now angle OMS, you first have to identify that angle. Which angle are we talking about? Yes, it is OM and S. So we are talking about that angle over there. So how are we going to find that angle, and how do you associate it with the information that was given here? Well, firstly, angle P, angle M, and angle S, they are equals to 180 degrees, because if you look at this bigger triangle, yes, it does form a triangle. So we know there that it is equals to 180 degrees because of the interior angles of a triangle. Then when we substitute, angle P we've calculated as 32, angle M is given there, or part of angle M is given there as 18, and O angle MS is the one that is not given to us, which is actually the one that we are calculating. Then we substitute the 43 degrees there, and that is equals to 180. Now when we simplify that, we know that O angle MS is equals to 87 degrees, and that is that question there. Let's look at the next question. It says there, calculate with reasons the size of angle R3 if TMS is 6 degrees. So we are told that TMS is 6 degrees. That means that here we are talking about this angle there. That will be the 6 degrees. Now, why is this important? It's because when we look at where angle R3 is, it is, of course, an exterior angle of that cyclic quad. So remember, just to highlight that cyclic quad there, this was the cyclic quad. So this was the cyclic quad over there. So just to make sure that we actually see the cyclic quad, and as you can see, the cyclic quad excludes the angle of 6 degrees there, and that's why that angle was given to us. Remember, when we calculated OMS, we calculated the whole angle, and we found that angle to be 87. But now if we take out this 6 degrees there, then that means we are left with 81. Now, thinking of that exterior angle of a cyclic quad, we know that the exterior angle of a cyclic quad will be equals to the opposite interior. And how do we see that it's an exterior angle of a cyclic quad? Make sure that one of the sides of the exterior angle is actually extending out there. So that's where we can see that that's an exterior angle. So the exterior angle is equals to the interior opposite angle. And which angle are we talking about? We are talking about that angle M there within our cyclic quad. So how are we going to solve for that? That means that angle R3 is equals to PMO, which is that 18 degrees there, plus OMT, which is that 81 degrees we just calculated there. This means this will be 18 degrees plus 81 degrees, and that is going to give us an answer of 99 degrees. And remember, the reason why we could make this conclusion is because of those exterior angles of, or that exterior angle of a cyclic quad. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So now we are going to look at a second example and see how we can apply those theorems. So looking at the second example there, it says in the diagram below, RS is a tangent to the circle at R, then RS is parallel to SAB. MT is equals to AB. So just from the given information, we are going to use that to analyze this diagram. Well, firstly, we are being told that RS is a tangent, and we know the theorems that come with a tangent. We know that the angle between a tangent and a chord would be equals to the angle subtended by that chord. We are also told that RS is parallel to SAB, and when it comes to parallel, we think of corresponding angles. We think of co-interior angles, and we think of alternating angles. So in short, when you see parallel lines, think of fun. Make sure you see these shapes or combinations when it comes to those parallel lines. And also we are told that MT is equals to AB. Well, we can see that MT is indeed a chord and AB is a chord, and because they are equal within the same circle, then that means that they subtend equal angles. Now that's us analyzing the question and making sure that we understand it. That will allow us to better answer our question. Let's look at our question here. It says if A angle BR is equals to X, name 3 other angles equal to X. So again, we have already analyzed the diagram and we've seen there, but let's look at where X is. Now where X is, firstly, it is being subtended by chord AR. Now remember that to subtend, it means we are either going to the center or to the circumference and no other place. So please do not think that AR is also subtending angle K1. Unfortunately, angle K1 is not at the center and it's not at the circumference, so it is not being subtended by AR. Now, what is the association that we have between that angle that is being subtended by chord AR? Well, we know that we do have a tangent, and this tangent is between a chord and a tangent, and that chord happens to be chord AR, which means that the angle subtended by the angle subtended by a chord is equals to the angle between the tangent and that chord. So the first angle that we have there that's equals to x is R1, and our reason for that is because of the tan chord. So we can see that it is that theorem that says that the angle between a tangent and a chord is equals to the angle subtended by that chord. What about the second angle there? Well, we can see that AR is subtending another angle there. So AR is also subtending angle M1. So we can see that they form that bow tie shape where it's AR is subtending angle B, which is X, and it's also subtending angle M1, which means that M1 is also X. And as we are finding out these values, we are going to fill them out in our diagram. So it means that the second angle there equals to X, that is angle M1, and our reason there is angles in the same segment. Of course, you can also say angles subtended by the same chord. What about the third angle that's equals to X? Our question did ask for 3 other angles that are equals to X. Now, when we are looking at our diagram here, we can see that we do have those parallel lines, and immediately we see there that our X is within alternating angles, which means that that angle there is also equals to X. So that means that R3 is equals to X, and our reason for that is alternating angles. And remember, when you state your reason as alternating angles, you need to also write down which lines are parallel. This is very important. So you need to add that TR is parallel to AB. And that's where the alternating angles come from. So let's get to our questions. The first question there says, O is the center of the circle below. SN is a diameter of the circle. And then angle M2 is equals to 64. Now determine with reasons the sizes of. So we're going to start by analyzing this diagram here. Well, firstly, we've been told that O is the center, which means a lot for us because we know that we do have those theorems that focus on the center. But again, we can see that within our diagram, we do have a cyclic quad as we have R, P, N, and M on the circumference of the circle. So we can see that that is indeed a cyclic quad. Now, what can we do to find the size of P? Well, we are looking at where P is placed, and we can see that P is equals to, or rather, we should say that M2 plus P is equals to 180, and the reason for this is because of the opposite angles of a cyclic quad. So the opposite angles of a cyclic quad, they add up to 180. So this means that 64 degrees plus angle P is equals to 180 degrees, which means that angle P is then there equals to 116 degrees. What about M1? So we can see that M1 there. Where is M1? Well, M1 is there on the side, and M1 is subtended by the points SR. But how can we find M1? Well, we can see that M1 and M2 are equals to 90. Now, why are we saying that M1 and M2 are equals to 90? Well, remember that O is the center, and right now we have a line that's passing through the center that's going from one side of the circumference to the other side of the circumference, which means that that is a diameter. And as we know, a diameter subtends a 90 degrees. So that means that M1 plus M2 is equals to 90 degrees, and the reasons for that will be angles in a half circle, angles in a semicircle, angles subtended by a diameter. All of those would be correct. Now, what is the value of M1? Well, that is what we are trying to calculate. So angle M1 plus that 64 is equals to 90 degrees, and that is going to be angle M1 is equals to 26 degrees. And that is the answer for our M1. Let's move on to the next question here. Well, the next question here says, determine with reasons the size of O1. Now we are still within the same triangle. So that means that those values that you've calculated in the previous questions, you should bring them over to this question. Well, we already know that M1 is 26 degrees there as calculated, and we know that P, or angle P, is equals to 116 degrees. Now what about O1? Look at where O1 is. Can you see that O1 is an angle that is subtended at the center? So we can see that O1 is subtended from points S and R. So arc SR is subtending angle O1, and of course is subtending because it's at the center. Now what do we know about angles subtended at the center? Yes, they are twice the angle subtended at the circumference, and as we've seen as well, SR is subtending angle M1. So this means that O1 is equals to twice of angle M1, and the reason for that is angle at the center is 2 times angle at the circumference, right? Which would mean that O1 is equals to 2 multiplied by M1, which is 26 degrees, which means that O1 is equals to 52 degrees. And that is the size of our O1. Let's look at another question. Now question 2, there again we have been given the diagram, and no matter how complicated this diagram might look, start by analyzing the whole diagram, see what you can pick up from your knowledge of theorems, and then attempt to answer the question. So it says there O is the center of the circle, so immediately we are thinking of the theorems that have the center in them. So O is the center of the circle, OT bisects QR at T, OY is parallel to QR, and R angle OY is equals to 20 degrees, while S angle RO is equals to 10 degrees. Now let's look at that diagram there. Of course, we know that O is the center there, but we also have a chord that is being bisected as we are shown in our statement, or as we are told in the statement. Now, if that angle is being bisected by a line that comes from the center, so that OT is coming from the center and it's bisecting a chord, already that gives us our theorem there that a line coming from the center that bisects the chord means is perpendicular to that chord. So we already know that there is a 90 degrees there. And if ever we are going to use that point, we need to make sure that we write all the reasons down. Now we can see again that XY is touching the circle at one point. We can see that it is a tangent over there. So those theorems about a tangent should also come to mind. We're also told that there are parallel lines there, which is OY and QR, which means, again, what do we think of when we see parallel lines? We think of fun. So that is how we are going to work with that. If there's anything we haven't seen here, we will see as we are answering the question. The first one we are looking out for there is S1. So where is S1? Well, as we can see, angle S1 comes from the 2 points R and Z, and it is being subtended at the circumference. But R and Z, they are not only subtending angle S1, but they are also subtending angle O1, and that is at the center. This means that S1 and O1, they have a relationship. That means that O1 is twice of S1. And the reason for that is angle at the center is twice the angle at the circumference. Right? And if O1 is 20 degrees, then that would mean that our S1 there is equals to 10 degrees. So angle S1 is equals to 10 degrees. What about R3? So looking at where R3 is, and make sure that every time you calculate a value, you are going to insert that value. So we know S1 is 10 degrees. Now looking at where R3 is, we can see that there is R3. And now R3 is part of alternating angles, as you can see there. So immediately we can see that R3 is equals to 20 degrees. And the reason for that is alternating angles. Now do you remember what your alternating angles reason should be accompanied by? It should be accompanied by the lines that are parallel. So we are going to say there it's because OY is parallel to QR. And that's our reason there for R3. Let's look at the next question here. We are still working with the same diagram. Remember, we just found 20 degrees for R3 and we have 10 degrees for S1. Now, determine with reasons the size of a P. Now, looking at where P is, we can see that P is there at the circumference. And if you look very closely, then you will see that PSRQ is actually a cyclic quad, which would mean that angle R2 and 3, when added with angle P, they will give us 180. So that means that P plus R2 and 3, they will give us 180 degrees. And the reason for this is because of the opposite angles of a cyclic quad. So when substituting there, we have P, or angle P rather. So we have angle P plus 30, because when you combine angle R2 and R3, it is 30 degrees. That is equals to 180 degrees. That means our answer there is 150 degrees. That is the value of P. Let's look at the next one. And there we are asked to determine the size of S2. Now, looking at where S2 is, if you look very carefully, you will see that S2 is actually subtended by chord RQ. So it is there subtended by chord R2, and that is the one, so RQ, sorry, and that is the one that gives us angle S2. Now, what we also notice about chord RQ is that it also forms an angle with the tangent. So what does this mean? It actually means that R4 and S2 are equal. But now the problem is we don't have the value for R4, so we can't really find the value for S2. But when we do look here, we do have a radius, a line from the center to the circumference of a circle, and we also have a tangent. And what do we know about a radius when a radius meets a tangent? Well, we know that they are perpendicular, of course. So we know that they form a 90 degrees there. So the first thing we can say there is that the R3 plus R4, that is going to give us a 90 degrees. And the reason for that is because we have a tangent that is perpendicular to a radius. Now that means that because we already have 20 degrees for R3, that means that our R4 is equals to 70 degrees. Now, us knowing that that is equals to 70 degrees, then we know that it means S2 is equals to that 70 degrees as well. And the reason for that is because of the tan chord theorem. So because of tan chord theorem, S2 is equals to 70 degrees. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our questions. So now we are going to go into a third question, and it reads, ABC is a tangent to the circle center O at B. EF is equals to BF, and angle BF is equals to 32 degrees. Now, we're going to start by analyzing this diagram here. For starters, we are told that ABC is a tangent, and automatically we should be thinking of our theorems that have a tangent. So since as well we are only working with one tangent, that means we are thinking of the theorem that says the angle between a tangent and a chord will be equals to the angle subtended by that chord. And then we are also told that O is the center, so we are thinking of our theorems that involve the center as well. And we are also told that FB and EF are equal. And as we can see, they are both chords to this circle. And what do we know about equal chords? Yes, we know that they subtend equal angles. So now, taking that knowledge into account, let's look at our questions. So it says they determine with reasons the size of E1. Now, looking at where E1 is placed, I hope you can see there that E1 is actually subtended by chord FB. So E1 is subtended by FB, but then FB is also the chord that is forming an angle with the tangent. So what does that mean? It means that E1 is equals to 32 degrees, and our reason for that is tan chord, right? Let's move over to the next question. And remember, as soon as we find a value, then we need to fill in that value over there. Now, the next question here is asking us for angle F. Now, looking at where angle F is placed, we can see that angle F is part of a cyclic quadrilateral. But unfortunately, because of us not having angle D as well, we cannot use that theorem here. Perhaps we will use it later, but in this case, we cannot use that theorem because yes, it is a cyclic quadrilateral, but we do not have any of those angles. But if you look closely there at the triangle EFB, so looking at triangle EFB, yes, we do have just one angle in that triangle, and that is angle E1, which is 32 degrees. But remember, those chords that we have been told are equal. So because those chords are equal, it actually forms an isosceles triangle. And we know that with an isosceles triangle, the opposite angles are equal as well. So now we can write there that B1 is also, or angle B1 is also equals to 32 degrees there, and this is because it is angles opposite equal sides, and that's why it is equals to 32 degrees. Now, because that angle is equals to 32 degrees, that means we can now find angle F. Why? Because angle F is within a triangle, and we know that the interior angles of a triangle add up to 180. So that means that angle F is actually equals to 180 minus 32 for angle E1 minus 32 for angle B1. And our reason for that is because the interior angles of a triangle. And then that would then mean that angle F there would be 180 minus 64, which then gives us 116 degrees. And that would be our answer for angle F. Let's move over to the next question, and always remembering that we need to fill out those angles. So every time we calculate an angle, we need to fill out that value. Let's go over to the next question, still under the same diagram, which means we still have 32 degrees with E1, we still have 32 degrees with B1, and we have 116 degrees with angle F. Now, looking at the question for C, it says there, determine with reasons the size of angle D. Now, looking at angle D, remember previously we discussed that yes, they are within a cyclic quad, and that is because EF B, and D, they form a quadrilateral, and they are a cyclic quadrilateral because those points that we just mentioned now, they are on the circumference of the circle. So this means that angle D plus angle F, they are actually equals to 180 degrees, and this is because they are opposite angles of a cyclic quad. So they are opposite angles of a cyclic quad. So what does that mean for angle D? Well, we already know that angle F is 116 degrees, and when we calculate that, then that means that D is actually equals to 64 degrees, and that is the size of angle D. That is 64 degrees. Let's look at the next question there, D. It asks us for O1. Now, when we are looking at O1, there it is there. We can see that it is an angle that is subtended at the center. And what do you know about an angle that is subtended at the center? Well, we know that the angle at the center is, the angle subtended at the center is twice the angle subtended at the circumference. But you need to make sure that they are being subtended from the same 2 points. Here we can see that chord EB is the one that's subtending O1. At the same time, chord EB is subtending angle D. So we know that O1 is twice angle D. And since as well we've just calculated angle D, that means that O1 is twice of 64 degrees. And remember, don't forget to write your reason. So we are saying that O1 is twice of angle D because angles, or angle at the center, so angle at the center is 2 times angle at the circumference. So we always need to make sure that we always include those reasons. So now we know that angle O1 is actually equals to 128 degrees. Why? Because if you multiply 64 by 2, then we get 128 degrees. Let's look at the next question, still within the same diagram. Now remember, we have 116 for angle F, we have 32 degrees for angle E1, 32 degrees for angle B1, we have 128 degrees for O1, and we have 64 degrees for angle D. All of these angles are important if we want to find those angles that are being asked for. Now, E asks us to determine, again with reasons, the size of E2. So we are going to calculate the size of that angle over there. But now looking at this angle over there, it is, yes, within a triangle. So we can see that a triangle is being formed there. And E2 finds itself within that triangle. But that's not the only thing about this triangle. We also see that we have equal lines in this triangle. How do we have equal lines? It's because OE is a radius and OB is a radius. So what does this mean? Now, because OE is equals to OB, and the reason for that is because both of them are radii, this means that we have an isosceles triangle where we have two opposite sides that are, we have two sides that are equal, which means the opposite angles are also equal. So definitely we know that if we take O1 and we add it to, or rather, let's first write that E2 will be equals to B2. And the reason for this is because they are angles opposite equal sides, right? And now if we say O1 or angle O1 plus angle E2 plus angle B2, they are equals to 180 degrees, and the reason for that is because they are interior angles of a triangle. Now, we already know that E2 and B2 are equal, so it means that we can say that O1 plus twice of E2 is equals to 180. We've already stated a reason why we are doing that, and it's because they are equal. Then we know that O1 is 128 degrees. When we take twice of E2, because it's equals to B2, that is equals to 180 degrees. We are actually not equating them. That's 128 degrees plus twice of E2 is equals to 180 degrees. That means that twice of angle E2, if we say 180 and we subtract that 128, then we are going to find an answer of 52 degrees. And because we want to find the value of E2 alone, that means that E2 or angle E2 is actually equals to 26 degrees, and that is the size of E2. So we know now that E2 is 26 degrees as well as B2 is 26 degrees. And just to check there, you need to make sure that those angles, when added, they add up to 180 degrees. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson, where here we are going to wrap up this wonderful lesson that we just had. Now remember, our focus was on Euclidean geometry, and this is the circles. And we all know those theorems that are included within this topic, but in this lesson, we only focused on 5 of those theorems. Now, when it comes to the keywords that we use when we are working with Euclidean geometry, those are words that you should be used to and should know what they mean. And you should also be able to associate these words with our theorems. Let's talk about the common mistakes or errors and misconceptions when it comes to Euclidean geometry. Now, the learners do not know the theorems well enough, so you need to make sure that you practice those theorems. And even if you do know those theorems, you need to know how to apply those theorems to the questions, because the other error here is that we might know the theorems, but we don't know how to apply those theorems. And lastly, learners do not know what it means to subtend an angle. Remember, when we are talking about subtending an angle, we are either taking it to the center or to the circumference of the circle. So we need to make sure that we know what it means when we are working with these theorems, that we need to apply subtending an angle. Don't forget these skills that you need to polish when you are practicing. Make sure that you enlighten these skills. You make sure that they become better and better so that you can be ready when the exam comes. And lastly, there is no way of knowing maths without practicing. So the only way you can know this mathematics is by doing the mathematics. There are additional papers that you can use to practice, but of course you always have access to more papers that you can practice with. Thank you for joining us for this wonderful lesson. We hope to see you next time. Goodbye.